Hey guys, welcome back to the channel and this new tutorial on Pytorch. So in previous few videos, we started learning about position embeddings, one of the core components in transformer model. In previous video, we mainly focused on verifying desired properties like how the relative position property holds, and if we run it through the linear transformation, whether it holds or not. Also, only initial few dimensions matters at the end, not all of them. So there was an minor issue which was pointed out by one of our viewers, Denise. So thanks, Denise, for that. And we will correct that and see if the properties that we verified whether it holds or not. So the issue was when I was implementing, we simply copied the above code in the below line, whereas in general one should be sine and the odd position should be cosine values. So we simply correct it. So what we need to do is we simply correct it cosine. Okay. So 2i should be sine values and 2i plus 1 should be cosine values. And now let us comment out this part and check them again, how it holds the relative position. So here it should be like P1 and P2 should be less distant compared to P1 versus P10. Okay, so the cosine distance between P1 and P2 should be less compared to P1 and P10. Okay, so let us run and see it. Okay, so you see the distance between P1 and P2 is 0.012, whereas a P1 and P10 is 0.14, which is much greater. Now, next property is to check whether the property still holds after linear transformation. So we implemented this check linear transformation property module where we pass through the position embedding through linear transformation, and then we get P1, P2, and P10 again, which is uh, linear transformed embeddings, and then we again check the distance. So this should be the same like we have at the moment. So P1 and P2 should have like less distance compared to P1 and P10. So let us run and see that again. So now if you look at here, it is similar behavior almost. So we get P1 versus P2 is 0.014 versus P1 versus P10 is 0.14. Okay, so that also holds. Now the last one is to check whether only a few dimensions are important, and that we can see we need to plot the embeddings. Okay, so we will simply plot the embeddings here. So let us do that as well. So in this part, we will take a sequence and we will plot the embeddings of that particular sequence. And let us say we have max position is equal to which is 100, and the dimensionality of the model is 512. And this is like the embedding of that sequence which has the length of 100. Okay. And then we simply plot it the embeddings versus token position. So let us run and see it. So now if you look at carefully, only let us say, so this is like the dimensions, 0 to 512 dimension are the dimension positions. Okay, so if we look at it carefully, after let us say 112 or 150 dimensions, it is static, like it doesn't change. Okay, so this shows that only initial few dimensions, let us say 150, are only important to represent the position embeddings of any dimension. Okay, so in this case we represented 0 to 100, and it won't change like even if you go further down, because the curve is kind of now goes somewhat parallel. Okay, so this video was mainly to correct the error that was there in the code and see if the properties that we thought to hold in position embedding still holds, and we can see that it still holds. So in this video we will stop here. In the next video we will start learning about subsequent masking. So thanks for watching. Bye for now. Take care. See you in the next.